Assalamualaikum and good day everyone. Today kita proceed lagi with chapter 2, Bending Stress and Shearing Stress. Because last week kita dah masuk on this new chapter and then proceed saja for this week. Alright. Okay, first kita akan tengok example number 2. Sebab kita dah belajar example number 1 last week and also we done one exercise. For example number 2, repeat the problem in example 1 if the cross section is as figure. Macam dalam example number 1, dia dah bagi like the distribution of the beam. As in like loading daripada on the top of the beam that acted being transferred to the beam. Okay, jadi loading tu sama macam example number 1. It just that the cross section je yang berubah. Macam example number 1, it is rectangular but right now it become T section. I hope that I rasa lah masa you semester 1 PJM 132 you have learned from Dr. Izzat. Dia dah ajar kan, ada a few sections that you pernah tengok sebelum ni. T section, you have I section, you have C section, you have hollow section and many others. Okay, first what we need to find is we need to find the IXX. Okay, jadi ini adalah our cross section here. So from this cross section to find IXX, it's better for us untuk kira the area first. Later on senang kita nak kira the center of gravity and then calculate the IXX. So for the first area, so I pick up the shaded blue one. So I namakan dia 1. Okay, I kira the area which is 500 mm times 100 mm. Okay, sebab dia punya dimension dekat sini if you look at this figure. And for area number 2, what we can see yang shaded with the red color one, okay, the area dia adalah 100 by 400 mm. Jadi 40,000. And total up everything you dapat 90,000. So that is the total area of the cross section. And then we calculate the centroid or X bar. To calculate the centroid for X bar, okay, I believe that you pernah tengok this formula ataupun before this I think you did the calculation in table. So sebenarnya if you translate into the formula, sebenarnya formula dia macam ni. Jadi keluarlah table yang you belajar like before, like previous semester. But because okay, masa you semester 1 memang you focus on learning how to calculate the centroid, as in the marks huge on that. Maksudnya the big portion of marks memang on COG. But for this semester markah yang banyak ada dekat the stresses and you kena calculate bending and shearing. Therefore centroid ni markah dia mungkin 1 atau 2 sahaja. So you're not going to waste your time untuk buat those tables which not a huge sum of marks being distributed there. Therefore kita pakai formula untuk simplify everything. So how you going to calculate the centroid? You use this formula. What is A? A tu area lah. X tu distance from centroid of the area yang you tengah kira tu pergi pada axis. Okay, axis tu depends kat mana you nak letak. So as in for my calculation here, axis ni I put at the top. You can put it here as well, no problem. Depends on you as long as you faham. Kita akan kira semua distance daripada x-axis. So here I letak x-axis at the very top of the cross section. So distance daripada x-axis to the area yang you calculate, right? So sekarang kita ada dua area which is area 1 dengan area 2 ni lah. And then at the bottom of this formula you nampak dia minta total area. Total area saja you divide. Apa maksud x1 tu tadi? As I mentioned, distance from centroid to the axis. Maksudnya axis, contohnya kat sini x1, x kat sini lah, sorry. X ni x axis And then we have X1 here. Maksudnya X1 yang ni lah. Right. So 50K, 50,000 is the area for the first yang shaded with the blue color. Darab dengan distance daripada centroid of that shaded blue area pergi ke axis. So you know that this is 100 mm height. Therefore, kalau you nak dapatkan distance ni, should be half of it lah. 100 divided by 2. Then you dapat 50 mm. And then for the second area, which is shaded with the red color, 50,000, okay, area number 2. And then you times with 300. So how do I get this 300 mm? If you look at where I letak all those arrows tu, okay, here you nampak X2. Okay, jadi kalau you tengok daripada centroid ni pergi ke the axis here, pergi ke atas ni lah. Axis kat mana you letak? Kalau you letak kat bawah, semua pergi ke bawah. Kalau you letak kat atas, semua ke atas at the very bottom, at the very top of the beam. So you tengok 400 divide by 2, so you dapat ini 200. So 200 campur 100 here. Okay, ini 100. So you dapatlah this 300. And then you divide with total area, which is 90K ni, 90,000. And you dapat the value for centroid, maksudnya daripada X bar, sebab semua you kira ni dari X bar. Jadinya you dapat value centroid ni daripada top, mungkin 161 tu mungkin kat sini lah. Okay. Jadi centroid dia adalah 161.11. Kat sini sebenarnya centroid of this whole section. And then we're going to calculate for second moment area, IXX. And we know the formula is BD cube over 12. Okay, mind you, BD cube over 12 ni mungkin sebelum ni you nampak I tak tulis this AH square sebab I buat rectangular section, because we know that the H value adalah 0. So when H value 0, jadi 0 darab A kuasa 2, kosong. Darab area pun kosong. That's why I tak letak this one But here we have this because H ni ada value. Dia ada distance bukan kosong. Sebab you punya section ni T section, dia bukan rectangular simple macam ni. Kalau rectangular tak ada lah. So first what we need to do is, okay, tandakan. Okay, here I dah mark lah this 161.11 ni kat mana. As you can see here dekat gambar ni, I dah tanda dengan warna hijau, garisan hijau ni. 161.11 from the top, the very top of the section ni. Okay, and then kita akan kena calculate using the formula of BD cube divide by 12. Kita calculate for the first area atas ni dulu. Okay, therefore the BD cube over 12 masukkan saja B tu 500, D dia 100 mm cube divide by 12. So ini tak ada masalah. However, for the second one, AH square ni, A tu area dia lah, which is 50K ni, 50,000. But we need to find the value of H. So H ni apa? Distance from the centroid of the first area ni, area nombor 1 ni, area shaded blue ni, pergi ke centroid semua. Okay, pergi ke centroid semua. Jadi mana jarak dia? You akan nampak yang I tanda. Nampak tak? Ada arrow ni. Okay. Dia tanda X1 bar. So we need to find that. We know that from top to the centroid ni adalah 161.11. And then we know that half of this height of area number 1 adalah 50. So atas ni 50 kan? Jadi 161.111 minus 50. Minus 50 ni. So you akan dapatlah jarak x1 bar, which is 111.111. And then we going to do for the second area ni pula. Right, so for the second area B D cube ni tak ada masalah, 100 darab 400 cube bagi 12. Masukkan sebab A H square and then A dia adalah 40,000 according to this one and then darab dengan H square dia. For H square, okay, you tengok sini 138.889. So how do I get this? Okay, you look at this figure again. You akan nampak jarak dia dari mana ke mana. So semua pergi ke centroid of the whole section, which is x2 bar here. Macam mana you nak dapat jarak ni? So you tahu daripada atas ni pergi ke x2 bar adalah 300, betul sebab daripada atas ni 100, so 400 bagi 2 ini adalah 300. Jadi 300 you minuskan je dengan 161.111. You punya centroid tu you akan dapat 138.889. Okay, and then you kira lah for the whole thing. Hopefully semua okay tekan calculator for calculation like this. Normally for IXX kita akan tulis by 10 kuasa 6 lah, and millimeter kuasa 4 for the units. And then what we need to find is, usually we going to find for the reaction. But for the reaction, since dia cakap sama macam example number 1, except for the cross section saja different, so the reaction should be the same macam example number 1. And also for SFD and BMD sama juga macam example number 1. Maximum shear force 5 kN and maximum bending moment 15 kN meter. Okay, first come first lah. Okay, next kita akan kira bending stress. So for bending stress, this is our section. What we going to do, kita as usual, we going to divide it into 5 points. So usually for bending stress, this section I akan divide like this. Okay, so you ada A, B, and then somewhere near the centroid bukan somewhere near, at the point of the centroid lah. So ini you punya centroid So kat sini C, centroid dia. And then I divide, sebab you ingat I cakap mesti ada top, atas kali mesti ada, bottom point mesti ada, centroid mesti ada. Okay, and then B ni I buat sebab saja tambah lah. So kita nak 5 points. And then sorry, ini E. D you akan letak, usually I akan bahagikan 2, but it's up to you. Okay, so maksudnya jarak antara C ke E ni I bahagi 2. Jadi bagi 2 dapatlah point D in the middle Buatlah garisan yang ni semua ni, garisan ni semua supaya kita boleh lukis later on untuk you punya notes Okay, so first we going to look at saya tandalah X bar tu, maksudnya X bar tu centroid dia kat mana you terus letaklah 161.111. So that's senang kita buat calculation later on. So kita going to calculate for point A first, right? So for point A, you know the formula for bending stress. My I 15 tu maximum bending moment. Okay, darab 10 kuasa 3 convert kilonewton to newton, and 10 kuasa 3 convert meter to millimeter, and times with Y. So Y here should be from the point, okay, distance from the point to the centroid of the whole section, which is 161.11 lah. Sama je macam kita punya ni, sebab kita tahu daripada top of the beam ni, distance dia sebab centroid kita lah 161.111. Then you dapatlah some values here which is positive, so it become compression. And don't forget your ISX which is 1963.889 that you calculated in the previous slide. And for point B, okay, I'm not going to explain about M and I. I'm just going to explain about Y. Okay, but Y, so distance from the point B to the centroid of the whole section, which is, you know, daripada top to the centroid, it is 161.111. So you just minus with the 100 sebab you ada 100, you nak dapatkan jarak ini kan. You nak dapatkan jarak ini. Jadi 161.111 tolak 100. You akan dapat 61.111. Okay, that is for point B. And then we're going to look at point C. So for point C, okay, point C memang dekat centroid. Alright. Distance Y adalah 0 because you punya centroid kat sini, dekat point C ni, and point you juga dekat C. Okay, jadi distance tak ada jarak untuk x-axis tak ada jarak. Jadi kosong lah. And then for point D, kita akan tengok dekat mana. So point D, as I said, I bahagi 2 between these two. Maksudnya point C dengan point E kat sini I bahagi 2 betul. Jadi I letak point D here. And you see 169.444. So how do I get this? As simple as 500 minus 161.111 and you divide by 2. Macam mana you dapat 500 ni? Sebab you tahu daripada atas, daripada top, okay, top like betul-betul ke atas ni adalah 500. Okay, top. Maksudnya ketinggian the whole section of the beam adalah 500. 500 you tolak sebab you tahu ini adalah 161.111. So 500 tolak 161. So you dapatlah panjang daripada sini ke sini. Okay. So berapa panjang ni you bagi dengan 2. Divide dia equally. Okay. Sebab panjang ni you bagi je 2. Dapatlah 169.44. But because of the point is below the centroid, therefore negative here, which means bila you calculate you akan dapat dia adalah in tension. And then that is for point D, and we're going to look at point E. So point E, negative 338.889 for Y. How do I get this? Sama je lah, because of you know that ini adalah 161.11 and then this is like 500. So 500 minus 161.111, you're going to get the distance from point E to the centroid of the whole section, which is 338.889. And don't forget the negative since it is below the centroid, which means when you are done for the calculation, you akan mark dia as intention. Now we're going to look for shearing stress. How kita nak solve shearing stress pula ya. For shearing stress, to divide dia in a different way sikit shearing stress ni. Okay. As what I told you, kita divide dekat top, bottom and centroid. Ini centroid lah. So we have one point here and point here. Normally kita akan divide into 3 into 5. And then kat sini lain sikit sebab kat ini ada lagi 2 point dekat sini, dekat tempat yang sama Kenapa? Maksudnya point B and point C dekat tempat yang sama dekat sini. Because we have difference in T, the thickness. Kalau you tengok formula for shearing stress, it is tau say it. T ni thickness. Okay, thickness ni selalunya kita ambil kan berapa panjang, for example this one berapa panjang ni thickness. Contohnya 500. Ataupun kalau point E ni maksudnya 100 lah, sebab sebelum ni you belajar ada rectangular. So rectangular semua point ni pun you tak point kat mana-mana pun semuanya sama. Okay. Jadi in our situation right now, sebab dia ada difference in thickness. Okay. Ataupun breadth dia lain. Dah berubah daripada 500 become 100. Therefore point B dengan C ni dekat tempat yang sama. And then we have point D dekat centroid. So you ada 5 points juga. So kita buat shear stress for the first point, which is point A. So for point A, nampak say it blah 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 kat situ. Okay, for point A here memang kosong lah. Okay, tak ada area, sebab kalau you tengok pun macam yang I ajar sebelum ni, no area. Tak ada area above point A ni. Point A kat mana? So point A at that particular tempat ni. So area above dia tak ada beam area above A. So area tu memang kosong. And when there's no area, there is no Y lah. Since Y dia kosong juga, tak ada area, tak ada distance from the centroid of area above A to the centroid of the whole section. Tak ada. Okay. And then for point B, here yang shaded with the blue color, area above B. Right. So for point B, S maximum shear stress, darab 10^3 kilonewton tukar to newton, and then area above B. So how do you get area above B? It is 500 darab dengan 100, semua yang shaded with blue color ni. Then you darab dengan Y. So ini adalah area. And this is Y. And Y, how do I get this? From centroid to area centroid to the very top of the beam ni, you punya X bar COGU 161.111. Okay, jadi you tahu juga panjang ni separuh daripada height of area above B ni adalah 50, sebab 100 tolak 50. Ini dia. So 100 divide by 2. So 50 lah. Maksudnya 161.11 minus 50. Then you will get 111.111. Then you divide with I that you dah calculated, and then T which is the thickness. Maksudnya sebab B kan, point B kat sini. Okay, ini masih lagi 500. Dia punya T dia. For C. Okay, C pun share at the same point. Maksudnya macam point B. Okay, letak dia kat tempat yang sama. Because of there is difference in thickness here. So kalau you tengok the calculation sama saja for A and Y, sebab area above C sama dengan area above B. However, if you look at the value of T, thickness, sebab dia tengah kira dekat sini pula. Sebab thickness dia berubah, which become 100. Therefore, perubahan dia dekat the thickness itself lah. Okay, Y dia semua sama. And then we have for point D. So for point D, kita nak kena kira sebab dia sekarang any area above D ni, semua area kat atas tu adalah termasuk dalam point D. But because of kat sini dia ada difference sikit perubahan kat sini, maksudnya kita akan bahagi dia dua. So kita akan kira for the first one, this one lah, untuk kat sini. And then this one kita akan kira dekat another one here. So that's why kita kira the first one first. 500 darab 100 sama je, 500 darab 100. And then darab dengan 161.111 bahagi 100 divide by 2, which is dapat 111.111. Sama je macam you kira untuk point C dengan point B ni. Sebab kita tengah kira area yang sama kan, macam kita kira point B or C here. Sama je area dia. Sebab kita tengah kira untuk area yang atas jadi distance dia to the centroid tu sama. Ada additional dekat sini sebab you ada another area here. Right? So for that area, kita akan kira area dia pula. Untuk area dia, okay, I ada tanda juga balik warna biru ni, tapi kita kira untuk that particular area saja. So for area number 2 here, A2 lah senang cerita. So ini A1 untuk area D1 ni area 2 dia lah. Okay. So for area 2, it is 100, okay, dia punya width is 100 and then the height is obviously 61.111 sebab you tahu daripada top ke centroid 161.111 tolak 100 ni, so you dapatlah height, balance height yang ni kan, which is 61.111. okay, so that is for the area. And for the distance from YD2 ni, okay, kita nak dapatkan YD2, maksudnya centroid untuk area yang kita kira ni ke centroid semua. So kalau you dah dapat daripada sini ke kan, you dapat 0.111, so obviously kalau separuh dia adalah 61.111 divide by 2, dan you dapat 30.556. Itu cara dia. And then you calculate everything, you will get 0.146. Okay. Kat sini kalau you tengok tak ada lagi simetri value yang lebih kurang sama because tak ada sama sebab point kita tak simetri. And then for E, mark dulu, okay, paling bottom. Then the area for all, which is 500 times 100. Okay, kira 500 darab 100 ni area atas. Sebab above E ni semua And then 100 darab dengan height dia, which is 400. Area semualah. Okay. And then since kita tahu centroid dia memang kat tengah-tengah untuk area semua ni, centroid dia memang kat sini. And centroid untuk semua ni juga kat sini. Jadi kosong lah Y dia. So ini semua adalah area. Dan ni adalah Y. And you darab, you dapat kosong. And notice juga, I lupa nak explain. T, semua yang dekat bawah ni T dia dah jadi 100. Because dah ada change in T here. That is for shearing stress. And then we need to draw the diagram. So from the value yang you dapat, first kita lukis the bending stress, right? And mark everything here. A, B, C, D, E. Okay, so for A, you masukkan 1.231 which is in compression, belah kanan lah. And then 0.467 positif juga kanan. And then for C, bending stress kosong. And then D, it is 1.294 negative, so it is intention. And for E also value the negative, intention negative. So you buat garisan, then you will get something like this. And for shearing stress, sama juga, mark everything and put the value for each point. So since dekat point B and C ni, as you can see, it shares the same spot. Dia ada dua value dekat sini. So 0.028 for point B and 0.141 for point C. And then just put straight line. And then point D is 0.146. So dia naik sikit. And then it come to 0. So make sure it is curvy. Value dia should be curvy like this. Then that's all for example number 2. I hope you understand on this particular example, because this is very important, this section. Alright, so I'll see you again in tutorial class. Okay, thank you so much and have a nice day. Stay safe everyone. Bye.